Hello, so this was a question two below one I did a week ago. So let's go over it. You and a friend play a game where you both select an integer 1 to 100. The winner receives $1 from the loser. The winner is a player who selects the strictly higher number. If there's a tie, then nothing happens. However, a player can also win by selecting a value that is exactly 2 below the larger integer. For example, if you select 80 and your friend selects 82, then you're the winner. Uh, Assume both you and your friend play optimally. The optimal strategy here is a mixed strategy, where you select a random value x from some approximately determined distribution. Find the variance of this. Okay, so basically, the idea behind this question is that we definitely want a number that is relatively high. If it was low, then we would have no chance of winning, right? So the hint inside here that really helped me out to solve this question was, suppose you were planning to select a value n. Note that n plus 3 is strictly better than n, as n plus 3 will beat all integers n would beat, as well as the integer n plus 2. So whenever it's possible to select n, you would select n plus 3. So what this essentially means is that we can narrow down the numbers of selecting from 1 to 100 to just three numbers, 98, 99, and 100. Because if we have 97, 100 is 100% definitely better than 97 because it beats every number that 97 could be. So that's why we would just narrow it down to basically just 198 and 99. This is kind of like now we can kind of see that it's kind of somewhat like a rock, paper, scissors game, where if we have 199, 100 would win. If it's 98 and 99 and 98, 99 wins. And if it's 98 and 100, 98 would win. So basically, this is just a rock, paper, scissors setup, and the odds of winning are exactly the same. So this would just give us the idea that we just play each one 1/3 of the time, right? Because if there's a tie, then nothing would happen. If it's the same, then we just vary it up. So yeah, so everything would have a probability of 1/3. I think that once you kind of realize up to this point that it's just a fair rock, paper, scissors game, then the variance is very easy to calculate. The question is basically solved. The last part of it is that basically this is just showing that 97, 96, 95 basically is just not the optimal strategy. So we're just kind of narrowed down to 98, 99, 100. And that each one is 1/3 of a chance. Our mean would just be 99. Our variance would be just the difference between each of them. So then it would just be 98 minus 99 squared times 1/3 plus 99 minus 99 squared. And then 1/3 of 100 minus 99 squared. So this expression over here. I think then it's just basically very simple math of this, and then our variance would be 2/3. I think the major thing that comes from this question that was kind of difficult was just kind of narrowing down 1 to 100 is just basically 98, 99, and 100. And then from there, you know that each one is a fair game, so it's 1/3 of a chance to play. And then the variance would just be found using the typical way of finding the things. So the expected value of x minus mu squared. Okay, cool. Let's end off here.